Seaborn is a visualization library that has been on top of Matplotlib. The only feature of it is that it provides a more attractive and informative statistics statistical graph. It's more attractive and informative. That's the only different. Because it provides a summary of all those particular aspects of Matplotlib. You will see that by example. So let me start by writing about Seaborn. This is number two. About Seaborn. So remember to connect your Google Club. Okay, I want to talk about some of the features of Seaborn. What makes different from Matplotlib. So Seaborn itself help you to build some default stylings. Okay, maybe you want to mark or you want to give colors, different colors to your plots. By default, so majorly blue, but you want to make some colors or various colors of this. You can do that using Seaborn. And it's also easier. By this, Seaborn has a very less code compared to that one of Matplotlib. It's very easier to do statistical plotting with Seaborn, and it also works smoothly with Pandas data frame. You want to create a simple data frame here, you see how it works with the data frame. Therefore, it helps in simplifying the complex visualization. As usual, before you work with this library, you have to import. There's the two basic ones that you won't forget. This obviously you work with them. You have to import pandas as PD. Meanwhile, you can be accessing your Google Colab and say import this particular libraries. Import numpy as PD. I mean as NP. Import matplotlib dot pyplot. You have to remember that pyplot as plt. Okay. You can also import. No, I want Seaborn. Import Seaborn as SNS. So here is how I have imported my Seaborn. Imported Seaborn. Okay, let me pick one call 1 minute. Hello. Yeah, good evening, sir. Pia niko salama. Oh, tumekuwa tukiplan ile meeting. eh, Actually sahii hata nimepost niko kwa meeting fulani, kuna training nafanya but inaisha by 9:40. Kama utakuwa by 9:40 itakuwa poa, but if not, of course tomorrow is na weekend, you can schedule it. Why not? What do you think? uh, uh, oh, hadi weekend. Sawa, acha basi kumaliza hivyo ni ku text ama ni call, and then now it's just a briefing. I think by less than 20 minutes will be done. Si kitu kubwa. Just understanding you. Yeah, sawa sawa. Alright, sorry for that. So there's a short call that I received. I hope now you've accessed your Google Colab. So want to plot line want to plot a line plot. Want to get an visualization of a line plot using Seaborn. Okay, so let me run this and I'm going to print. So let me plot my line plot. So let me start with the line plot. How do you do that with the Seaborn? Of course, you know what line plot was. I'm going to let me take my x to have some values like 1, 2, 3, 4, 5. Okay. Then my y can be something like, okay, 5, 10, 15, 20, 25. Then they'll be matching. Then for Seaborn it's very easy. For Seaborn it's very easy to plot that. I'm going to come here and call Seaborn like S and S dot, because I want to work with the line plot. I want to say line plot. Inside I'm going to pass X versus Y. So just by here, I will be able to see my particular chart. So what's the next thing that I want to do? I'm going to say plt dot show. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 5. There's an error I'm encountering here. So line plot text from 0 to again, but 2 were given. Okay. I'm going to say x axis. Yeah, there should be two. X axis to be that one, and then the y axis to be y. I think should this now work. Uh-huh. Yeah, exactly. So I am having a line plot for this particular data. My x, I'm having 1, 2, 3, 4, 5. For my y, I'm having 5, 10, 15, 20. So I plotted my line graph using Seaborn. So of course I can add other features like the title and say let me say line plot of line plot of let me give a descriptive title x and y. Then I can give the axis. I can say sns dot x label. Okay, sns dot x label y axis, then y label x axis. So let me run that and see. SNS dot x title is that. Okay. Okay. Oh, should be plot. What plot, sir? Uh-huh. So we have the plot. The axis there is the y-axis, the x-axis. So that's how you are able to get a line plot using Seaborn. What have I done in summary? What have I done? I have to import that library first because I'm using it. So I'm going to import Seaborn. Then after that, I'm going to define my data axis. In most cases, using the pandas, we'll be able to read our own data and then now write or get a particular graph from a real world data set. So after that, I'm going to define two particular parameters for x and y. I'm going to say my x to be on the y-x axis, and then y axis should have the value y. My x axis should be of this particular points. You can name it anything, maybe A and B, or anything. You can say boy and girl, or maybe two particular entries. Then for y-axis is will map from the y data. So after that, the most important thing is to show. So if you show that, you already have your plots shown. But to make it more fancy, I'm going to add the title and the axis to help me communicate it better. And then you have that. So let me take you quickly about quick on box plot. How you use Seaborn as well on box plot. Before I get question from you, let me call this one B box plots. Let me use bar plot first. Bar plot. I've imported Seaborn. I can import it as well. Import Seaborn as SNS. Okay. Then now let me define my data point. I can say students. Let me plot students against marks as well. Students. Let me say the first one is Emmanuel. The second one here, because we are two, let me say Wilberforce. Wilberforce. Your name is so long. Then marks. Let me just keep it simple with only two records. Marks amount to have 80, okay, versus 75. Now let me call my Seaborn to plot my bar plot. SNS dot bar plot. Then inside here, I'm going to say X, okay, to be students. Let me copy and paste it there. Let me just type it. Students. Then Y is going to be on the Y axis will contain their marks. So let me even run it up to here without calling the plot function. It's very simple. My I'm able to see my bar plot from here of two students against their marks. So let's see what we have. Let's see, Manuel. Yeah, that's perfectly fine. So I see the names versus their marks. So in my x-axis here, I'm having their in my y-axis I'm having their marks, while in my x-axis down here that I've defined here is their students. And just as simple as that for you to obtain a bar plot using Seaborn. So you can take this through to other plots, maybe box plot, count plot, all that. Let me try. Lastly, let me talk about box plot. Is I've mentioned it a number of times. It means I should plot it as well. So I've imported Seaborn. I'm not going to do that as well. Let me just give a data. My data points 12, 10, 12, 16, 11, 23, 18. Okay, that should be enough. Then we'll say SNS dot box plot. Box plot. Then my data is coming from data. See how simple is it? Only two lines I'm able to get this particular beautiful box plot. Okay, I'll help you define box plot later. By next week, I'll help you understand how to interpret box plot. Here I can see the mean is 14 at the middle. The uppermost data here, the highest is at 20 something, that's 23. The lowest state is at 10. Yeah, and that's what we have. This is the median, this is the median, and this is the mod, something of that sort. Yeah. It's so easy to use a box plot to do explanation. So let me take you through the remaining visualization. That's how Seaborn works. Let me take you through the remaining visualization. We talked about scatter plot, so let's talk about Seaborn heat map. What's called a heat map? Heat map. So I can use a very simple plot. Haina shida, acha nikuonyeshe. Sawa, unajua pia na record, nitashare link pia tumaliza haraka. So you just get it at the first point, the raw information first. But of course, the time for question will be asked. I'll repeat everything. But they just the same thing repeating itself. So nothing new. Let me talk about heat map anyway. This was the third one. Or let me see. This should be C. You can say heat map. Heat map is one of the common graphicals. I mean graphs to show you what's called correlation. Just to show the relationship between different uh, data points or variables. In a similar way, you work with another best example is a scatter plot. This one here. It also helps to show relationship. So an extension of this, okay, you see, it was used to show relationship as well. So an extension of that or a transformation of that is what's called a heat map. A heat map is made of a number of cells, like in Excel. Let me show you how it looks like. So I've imported Seaborn, I've imported pandas. I'm not going to do that as well. So let me define my data points. I'm going to have a library of data points. Let me say maths, this is a dictionary. Then I'm going to match it with, let's say maths. I'm going to match it with the value like in my class. These are the score for maths, for mathematics. The first one is 780, the second one 43, 67. Which one? Let me balance it. 50 and maybe 91. Okay. My second subject is science. Science. Let me define a dictionary of this particular values. So for science, my first student has 85, the second one has 70, the third one has 95. Uh-huh. Not really, that's so low. 56, and maybe 60. Yeah. So for maths, I'm working out for one student for maths. My class maths students 80, 43, 7, 50, and 91. While for science, I'm having 85, 70, 95, 6, and 60. And they should be matching. So I want us to draw a heat map because we have learned that whenever you work with data frame, you have to convert it to when you have a dictionary like this. I want to call the data frame function to convert my data to what's called a data frame so that I will be able to plot it. But in normal cases, I'll show you, we'll just read our own data, then generate our own heat map. So let me call it a data frame pd dot convert everything to data frame, my data. Then I can call now my Seaborn library sns dot heatmap. Then inside I'm going to pass my, let me pass the relationship. I'm going to say df dot correlation analysis. I'm checking the relationship. Then the notation I want it to be true so that I'm able to see the labels. And this is like the labels. You'll see that once I generate the graph. I think everything is perfectly fine. Okay, that's great. So let me run this and see. Yeah. So this is how heat map look like. Mr. Wilberforce, can you hear me? Hello, Mr. Wilberforce. Okay. Have you ever seen something of this sort in just somewhere random, even over the internet? Okay. So this was called, okay, this is what's called a heat map anyway. It's used to show correlation. It's used to perform some, let me say, three basic tasks. You can do a correlation analysis like what I've done here. You can do financial analysis. You can do machine learning using your heat map. Whenever you'll be checking at the accuracy of your scores, you can check that by looking at the uh, heat map or even the what's called the precision recall functions. We'll see that when that particular point we have it. So I'm able here to see how my particular variables correlate. For example, let's just use this small one. Maths against maths. Maths on the y-axis against maths. That's a perfect correlation of value 1. Very perfect. Everything's aligned. If I plot maths against maths, I'm going to have just on the y-axis, I'm going to have a perfect line. Kumaanisha, they are perfectly matching, correlated. Now take a look of science against maths. 0.16. This is a weak correlation. Why? If you look at how the values correspond, there is a weak relationship. Doesn't matter. No value influence the other one. So there's a weak relationship. So that's how you are able to check that by checking on the x against the y. Mass against math, one perfect correlation. On my right, I have a scale all the way from 0.2 to 1.0. The scale will always be distributed based on how the correlations are. For instance, if I had my first value as 0.5, you can get your first scale here maybe from 0.4 up to the highest. If I had my highest correlation to be 0.95, I could have here maybe it's like 0.98 to be my highest. So that's how it operates.